Mathematics for Computer Scientists, Exercise 4, Question 5. Test the truth of the following assertion. So let's start with P or Q. Writing all possible values is an area that people often make mistakes. All you need to do is to write a simple binary counter. So we have 0, 1, 2, 3. The OR statement is true when either P or Q is true. So in the first one, neither is true, so the output is false. In the second one, Q is true, so the output is true. In the third one, P is true, so the output is true. And in the fourth one, both are true, so the output is true. The next thing we need to look at is not P and not Q. So for not P, just look at this P column here, and everywhere there's a 0 put a 1, and vice versa. And the same is true for not Q. Not P and not Q is true when both not P and not Q are true. So that's the first line, and then everything else is false. So if we look at this column here and this column here, they're not the same, which means that the assertion is false. Question 2. P implies Q. Well, as before, we'll start off with a P and a Q, and we'll write them in the same way. The implies statement here is true when the first term is false. So those two values there will give us true in the output. When the first statement is true, you take the value of the second statement. So P is true, Q is false, so the output is false. P is true and Q is true, so the output is true. So that's the truth table for P implies Q. Now we need not P and not Q. So everywhere P is false we write true, and everywhere it's true we write false. And the same is true for Q. Everywhere not Q is false we will get a true output, and then where not Q is true we need the value of not P. Now looking at the two right hand columns, this is the same as this, which means that the assertion is true. This time we've got P and Q and R. So we do the same procedure, but this time we've got 3 inputs and we just count in binary. So we have 0, 1, 2, 3, 4, 5, 6, 7. Now we want P implies Q. Whenever P is 0, the output will be 1. And whenever P is 1, the output is the same as Q. Now we want Q implies R. So as before, whenever Q is 0, the R will be 1. And whenever Q is 1, the output will be the same as R. And now we need to AND those two statements together. So whenever P implies Q is true and Q implies R is true, we'll get a true output. So that's the truth table for the left hand side of the assertion. So let's just give ourselves a bit of space. Now we need R implies P or Q. So we'll set out our truth table as before. P or Q is true when P is true or Q is true. So it's 0 and the rest are 1s. You can see there are 1s here and there are 1s here. And now we need R implies P or Q. So wherever R is 0, the output is going to be a 1. And wherever R is 1, the output is going to be the same as P or Q. and this column are not the same, so the assertion is false.